Ladies and gentlemen, what if every second you spend on the road is being tracked, calculated, and silently charged by a system you can't see, but it sees everything? Imagine driving through a world where the road is alive, where machines predict your every move before you make it, and where a single decision, one turn, one acceleration, could cost you more than you ever expected. This isn't the future you were promised. This is a system already being built, powered by artificial intelligence, massive data networks, and machines operating at a scale beyond human control. And once you're inside it, there's no turning it off. And the road is no longer just asphalt in motion. It's becoming a data stream, a measurable system, a network where every kilometer you drive is tracked, calculated, and priced in real time. This new driving tax isn't a traditional flat fee or annual payment. It's dynamic, intelligent, and powered by advanced infrastructure designed to monitor movement at scale. Every acceleration, every route, every second on the road feeds into a system that's learning, adapting, and charging accordingly. And imagine a world where your vehicle is no longer just a machine. It's a connected node in a massive digital ecosystem. Sensors embedded in roads, satellites tracking movement from above, and AI-driven analytics working silently in the background. The system knows when you drive, where you drive, how often you drive, and even how efficiently you drive. And based on that, it calculates your costs with precision that feels almost surgical. And this isn't about fuel anymore. It's about usage. The more you move, the more you pay. But it goes deeper than that. High traffic zones, higher rates, peak hours, premium pricing, congested areas, additional charges. The system is designed to optimize traffic flow, reduce emissions, and push drivers toward smarter, more efficient behavior. But it comes at a cost that can quickly scale into thousands. And vehicles themselves are becoming part of the equation. Modern systems are capable of communicating directly with central networks, transmitting data in real time without any human input. There's no need for toll booths, no stopping, no delays. Everything is automated. You drive and the system calculates. Instantly. Continuously. And it doesn't stop at location. Speed patterns, driving habits, and even route choices are analyzed. Smooth, efficient driving might lower your costs slightly, while aggressive acceleration or inefficient routes could push it higher. The machine is always watching, always optimizing, always adjusting the price. And what makes this system truly powerful is its scalability. It's not limited to one city or one country. It's designed to operate across entire regions, even globally. A unified network where every vehicle is part of a synchronized flow and every driver contributes to a massive, constantly updating dataset. The infrastructure is built to handle millions of vehicles simultaneously processing data at speeds that were unimaginable just a decade ago. And for some, this represents the future of smart mobility. A world where traffic is reduced, roads are used more efficiently, and environmental impact is minimized. But for drivers, the financial impact is impossible to ignore. What used to be a simple commute could now carry a variable cost that changes daily, even hourly. And there's also a psychological shift. Driving is no longer free once you own the vehicle. Every trip becomes a calculated decision. Is this route worth the cost? Is this time of day too expensive? Should the journey even happen at all? The system subtly reshapes behavior, nudging users toward alternatives without ever forcing them. And then there's automation. As vehicles become more autonomous, the integration becomes even tighter. Self-driving systems can optimize routes not just for time but for cost efficiency. Your vehicle could choose a slightly longer route if it means saving money, or adjust speed dynamically to stay within lower pricing brackets. The machine isn't just driving, it's strategizing. And at its core, this new driving tax is powered by one thing: data. Massive, continuous, real-time data. It transforms roads into intelligent systems and vehicles into active participants in a digital economy. Every movement has value, and that value is constantly being recalculated. And the result is a system that feels futuristic, seamless, and incredibly efficient, but also one that quietly redefines the cost of mobility. What was once predictable is now dynamic. What was once fixed is now fluid. And as the technology continues to evolve, the line between driving and being part of a network becomes almost invisible. And behind that invisible network, an entirely new layer of machines begins to emerge. Systems that don't just observe the roads but actively shape how they are used. Robotic infrastructure embedded beneath highways continuously scans surface conditions, detecting wear, pressure, and microfractures in real time. Maintenance is no longer reactive. Autonomous repair units can be deployed instantly, minimizing disruption, while ensuring the network remains optimized for maximum efficiency. The road itself becomes a living system, self-monitoring and self-improving. And above-orbital systems and high-altitude platforms synchronize with ground-based AI, creating a multi-layered intelligence grid. This grid doesn't just track vehicles, it predicts movement. It anticipates congestion before it forms, reroutes traffic dynamically, and adjusts pricing algorithms in milliseconds. Every vehicle becomes part of a predictive flow, guided by an intelligence that sees patterns far beyond human perception. And inside the vehicle, the transformation is even more profound. Advanced onboard processors constantly communicate with external systems, exchanging data at incredible speeds. The vehicle understands its environment with precision, mapping not just the road ahead, but the behavior of surrounding vehicles, infrastructure signals, and real-time pricing fluctuations. Decisions are no longer made in isolation. They are part of a synchronized network-wide strategy, and robotics plays a critical role in scaling this system. Massive automated manufacturing facilities are producing the sensors, chips, and communication modules required to sustain this ecosystem. These factories operate with minimal human intervention, using robotic arms, AI-driven quality control, and self-optimizing production lines. Every component is built to integrate seamlessly into the network, ensuring reliability at scale. And the data centers powering this system are equally advanced. Distributed across multiple regions, they process enormous volumes of information continuously. Machine learning models evolve in real time, refining pricing strategies, traffic predictions, and system responses. These centers are designed for speed and resilience, capable of handling spikes in data flow without interruption. The system never sleeps. It learns, adapts, and evolves every second. And what makes this ecosystem even more complex is its ability to integrate with other sectors. Energy grids, for example, are connected to the same intelligence network. Electric vehicles don't just consume power, they interact with the grid, dynamically adjusting charging times based on demand and cost. The driving tax system can factor in energy usage, creating a unified model where mobility and energy become part of a single optimized equation. And logistics and transportation networks are also deeply integrated. Delivery fleets, freight systems, and public transport operate within the same framework, each contributing data and receiving optimized routes. Autonomous trucks move in synchronized convoys, reducing drag and energy consumption while minimizing cost. Every movement is calculated, every route optimized, every second accounted for. And as automation deepens, the system begins to influence design itself. Future vehicles are engineered specifically to interact with this network. Lightweight materials, aerodynamic structures, and advanced propulsion systems are optimized not just for performance, but for cost efficiency within the pricing model. The machine is no longer adapting to the road and the system are shaping the machine. And at scale, the impact becomes even more significant. Entire cities can be managed through this network, with traffic flows optimized across millions of vehicles simultaneously. Urban planning evolves to align with the system, creating zones that encourage efficient movement while discouraging unnecessary congestion. The driving tax becomes more than a fee. It becomes a tool for shaping how cities function. And artificial intelligence continues to push the boundaries further. Deep learning models analyze historical data, seasonal trends, and even behavioral patterns to refine the system. The network can anticipate how drivers will respond to pricing changes, adjusting strategies to maintain balance. It's not just reactive, it's proactive, constantly seeking the most efficient state. And as the system grows, it begins to blur the line between control and autonomy. Vehicles operate with increasing independence, making decisions that align with both user preferences and network optimization. The experience becomes seamless. You input a destination and everything else is handled. Route selection, cost optimization, energy management, timing. The system orchestrates it all with precision. And what emerges is a world where mobility is no longer a simple act of driving. It's a fully integrated, intelligent process driven by machines, powered by data, and scaled across entire regions. Every journey becomes part of something larger. A synchronized network where efficiency, cost, and performance are continuously balanced by an invisible intelligence that is always learning, always adapting, and always evolving. And then the system accelerates beyond prediction into orchestration at a scale that feels almost unreal. Streams of vehicles move like synchronized pulses through illuminated corridors of infrastructure, each unit precisely spaced, precisely timed, guided by algorithms that operate faster than human thought. The highways transform into high-speed channels of controlled motion where latency is reduced to near zero, and every decision is executed with machine-level precision. And beneath the surface layers of embedded processors fire, continuously calculating load distribution, surface stress, and optimal velocity patterns. The road is no longer passive. It actively responds, adjusting microsignals that communicate directly with vehicles, guiding them into perfect alignment. There are no sudden stops, no unpredictable slowdowns, only a continuous fluid motion that feels engineered rather than driven. And in vast automated factories, production lines stretch, endlessly illuminated by cold, precise lighting. Robotic arms move in perfect synchronization, assembling components at speeds that blur the line between motion and stillness. Microchips are placed with atomic-level accuracy sensors calibrated to detect the smallest variations. Communication modules, tested against millions of simulated scenarios in seconds. Every unit produced is instantly integrated into the global network, ready to transmit and receive data without delay. And gigantic server arrays process incoming streams of information in real time, converting raw movement into actionable intelligence. Cooling systems hum quietly as processors execute billions of calculations per second, refining models, updating predictions, and recalibrating the entire system continuously. Data flows like electricity, fast, constant, unstoppable, feeding the intelligence that governs every kilometer of movement. And out on the roads, vehicles glide with calculated intent. Acceleration is no longer a reaction. It is predetermined, optimized down to milliseconds. Braking becomes almost invisible, executed in micro-adjustments that maintain perfect flow. Each vehicle maintains an ideal position within a constantly shifting formation, adapting instantly to changes that have already been predicted before they occur. And high-speed corridors emerge where vehicles move in tightly coordinated streams, separated by minimal distance, yet operating with absolute safety. The system calculates trajectories in advance, ensuring that every movement aligns with the greater flow. It's a choreography of machines where millions of independent units operate as a single unified system. And the scale becomes overwhelming. Entire regions pulse with synchronized motion, cities breathing in and out as traffic flows in perfect rhythm. The system expands, integrating new zones, new vehicles, new data streams without friction. Every addition strengthens the network, increasing its intelligence, refining its precision. And even the smallest details are optimized. Tire pressure, weight distribution, aerodynamic resistance. Everything is measured, analyzed, and factored into the system. Vehicles adjust in real time, subtly altering performance to maintain efficiency within the network. Nothing is left to chance. Every variable is accounted for. And autonomous logistics systems amplify the intensity. Fleets of delivery units move in perfect coordination, loading and unloading with robotic precision, their routes calculated to the millisecond. Warehouses operate as extensions of the network, with automated systems processing goods at incredible speeds, feeding into the same data-driven ecosystem that governs the roads. And energy flows are synchronized with movement. Charging stations operate as intelligent nodes, distributing power exactly when and where it is needed. Vehicles communicate their energy requirements in advance, ensuring that no time is wasted, no resource overused. The entire system operates like a closed loop where efficiency is maximized at every level. And artificial intelligence continues to evolve within this environment, pushing boundaries further with every cycle. Neural networks process patterns that span entire continents, identifying inefficiencies and eliminating them before they can manifest. The system becomes sharper, faster, more precise with every iteration. And the visual becomes almost cinematic. Streams of light moving through vast networks, machines building machines, data flowing endlessly through invisible channels. Every element operates in harmony, driven by a level of coordination that feels engineered at a scale beyond traditional comprehension. And within this relentless precision, the cost mechanism continues to operate silently, embedded deep within the system. Every movement, every adjustment, every optimization feeds back into a dynamic structure that calculates value in real time. The faster the system becomes, the more refined the calculations, the more granular the cost. It scales with the network, evolving alongside the machines that power it, becoming more intricate, more responsive, more deeply integrated into the fabric of movement itself, and it begins to reveal layers that were never visible before, hidden deep within the architecture of the system. Beneath the seamless motion and silent calculations, entire command layers operate in parallel, shadow networks of decision-making engines that constantly audit, refine, and override outcomes in real time. Every signal is verified, every movement cross-checked, every fluctuation absorbed and recalibrated before it can ripple outward. And massive underground facilities extend for kilometers, housing autonomous maintenance fleets that remain dormant until activated by microscopic deviations detected above. The moment a variation appears, pressure imbalance, surface inconsistency, or abnormal traffic density, these machines deploy instantly. Precision-guided units rise from concealed access points, execute repairs with surgical accuracy, and disappear back into the system before the flow above even registers disruption. And across the horizon, industrial production zones operate like mechanical ecosystems. Conveyor systems stretch endlessly, carrying raw materials through layers of transformation, cutting, shaping, assembling. Each stage monitored by vision systems that detect imperfections at a scale invisible to the human eye. Robotic clusters adjust in real time, reconfiguring workflows to maintain maximum throughput. There is no downtime, no pause, only continuous motion. And within these environments, sound is replaced by rhythm. The synchronized movement of machines creates a steady pulse, a mechanical heartbeat that drives production forward. Components emerge in perfect uniformity, each one calibrated to integrate instantly into the network. There is no excess, no waste, only precision output at a scale that continues to expand. And the environment itself adapts to support this flow. Smart materials embedded in infrastructure respond to temperature, pressure, and load reshaping at a microscopic level to maintain optimal conditions. Airflow systems regulate heat across vast spaces, ensuring that performance remains stable, even under extreme demand. Every variable is controlled, every condition engineered for continuity. And above ground, the visual intensity deepens. Streams of vehicles cut through illuminated pathways, their motion so synchronized it appears almost artificial. Reflections ripple across polished surfaces as light interacts with movement, creating a dynamic landscape that constantly shifts yet never loses alignment. The network is alive with motion, but nothing is chaotic. Every element follows a precise pattern, calculated and executed with flawless timing. And in the background, predictive engines grow more aggressive. The system no longer waits for behavior to unfold. It begins shaping it in advance. Subtle adjustments ripple through the network, influencing route speeds and flow distribution before congestion can even begin. It anticipates demand spikes, redistributes load, and balances the system with a level of foresight that feels almost predictive of intent. And deeper within the data streams, simulations run continuously. Entire virtual environments replicate real-world conditions at accelerated speeds, testing scenarios, stress points, and system limits. The results feed directly back into the live network, refining responses in real time. What happens in the simulation is instantly translated into action, collapsing the gap between prediction and execution. And autonomous fleets move with increasing cohesion, forming dynamic clusters that merge and separate with perfect timing. Their movement resembles a living organism, fluid, adaptive, constantly optimizing. Each unit is aware of the others, reacting not just to immediate surroundings, but to the entire system's state. The scale of coordination becomes almost overwhelming, and production continues to intensify. Facilities expand vertically and horizontally, creating multi-layered manufacturing grids, where thousands of processes run simultaneously. Raw inputs enter at one end, fully integrated components exit at the other, ready to be deployed instantly. The speed of transformation compresses what once took days into minutes, sometimes seconds. And energy systems surge to match this demand. High-capacity storage units cycle power through the network, balancing supply and consumption with exact precision. Renewable inputs are absorbed seamlessly, their variability stabilized by intelligent distribution systems. The entire grid operates as a synchronized extension of the mobility network, ensuring that energy and motion remain perfectly aligned. And within this expanding complexity, the system begins to feel almost self-directed. It evolves without interruption, refining its own processes, identifying inefficiencies, and eliminating them before they surface. Every cycle brings higher precision, faster response times, and deeper integration. And the visual field narrows into moments of intense clarity, Robotic arms moving in perfect arcs, vehicles aligning with millimeter accuracy, data streams flashing through processors at incomprehensible speeds. Each moment is a glimpse into a system that is no longer just operating. It is advancing, accelerating, and redefining the boundaries of what movement, production, and automation can become.